Okay, thank you. Okay, so okay, let us begin with the session. So, what we are trying to do today is today we'll this is one of the important sessions of the bootcamp. That is because most of the projects will have some kind of reporting, and we need to understand how do we populate data into the XLS or spreadsheet or whatever. So if we try to understand how do we how the Excel is organized, and then how to extract the data and put it there, then we can use advanced libraries such as pandas and all those libraries which can do automatically. So we need to understand step by step, and then we need to we'll write code for populating the data into Excel sheet, and then we will see how what are the other options for generating Excel sheets. Okay, so just revising. So yesterday we studied about web scraping. So there are infinite number of use cases in web scraping. You can do a lot of things. So basically what we're trying to do is we try to download the page in the background without browser. So forget the browser. So we have a library which is like a which does one of the parts that browser does. It just downloads the page. That is our request library, and then we parse it. How do we why do we need to parse it? Because it has a certain structure, just like JSON and XML. This is HTML page, and HTML is also like it's a markup language. That means HTML stands for hypertext markup language. XML stands for extensible markup language. The main difference between XML and HTML is that in XML all the tags that we use is user defined. Say for example, if you have a router, so you can define a router a tag called as router, and then you can define another tag saying routing tables and quality of service, port numbers, all these things. So that is why it is called as extensible markup language. Similarly, in HTML we have tags which are fixed. The reason that is fixed is because the browser needs to understand. Say for example, there is a tag called as title, and it is the responsibility of browser to make sure that the title is put as a title in the web page. So in order to do that, these tags needs to be fixed. So that is why in HTML this acts as a keywords for the browser. So browser is the one who interprets that and populates data into the browser. Okay, so that is the main difference between XML and HTML. So that is the reason we need to do the parsing. So parsing is based on the structure of the HTML content. So it is tree structure in terms of programming. So the root node contains the main HTML tag, and then the children contains title, body, and things like that. So you can grow it as many levels as you want. So that is about that is the need for parsing. And then we extract. After parsing, we try to extract the data. So in our example, parsing and extraction happen in one shot. That is because we are using beautiful soup library. So we pass parser in one of the as an arguments while creating an object out of beautiful soup, and then we also pass what is the data you need to extract out of it. So once you extract it, it comes as a list. So you can play around. There are a lot of options in beautiful soup. You can extract multiple nodes. You can extract based on text, things like that. So you can play around with that. So in order to play around with that, you need to do this exercise, because we have seen how it is built, and then you can try to parse any other website such as Flipkart, Amazon, or if you want to do research journals, you can simply collect all the blogs and all the research papers automatically, and then you can do a lot of interesting things. So once you get used to that, you'll try to understand how exactly the extraction and filtering happens. And then the final part comes to how do we transform it. So here in our case, we are not transforming it to any kind of document. So we are just putting as a simple text. So in fact, we can transform it to any other format and make use of that. Okay, so that is about scraping. So this is the HTML structure. This is a specific case of XML. That means the logic is the organization is same, but these keywords are fixed in HTML. Okay, so this is also called as document object model. So if you are a GUI programmer, that is UI programmer, you will come across this terminology called as DOM very frequently. So DOM is nothing but document object model, and it helps us to understand how the layout that we perceive visually from the browser. It defines that. So that is why it's called as document object model. So how the data is organized inside the document. So hands-on is you repeat the same thing, and maybe you read about other libraries. So and then let us get into today's session. Today's session is about extracting data from the API and then putting into an Excel sheet. So this is the key picture that we drew. So we did brainstorming, and we did some kind of picture, and out of that picture we have divided that into smaller parts, and this is one of the ways to put it in a formal way. So this is called as flow diagram, and then yesterday we focused on this part, news part. So today we are focusing on report part. So what we do in report part specifically in this session is we generate the Excel sheet. So that is about it. This is what we are trying to do. So we extracted news, and then we extracted API data. Now out of that we are trying to extract API the data and put it in the reports. Okay, so that is to set the context. So let me just I do not have many slides for this because I want to draw it out and explain how things work. Okay, so let me just try to draw things. Okay, so in order to understand Excel sheet, let us go back to the basics. The basics is nothing but we have a RAM in the first class. We have RAM, and we have the CPU here, and we have a hard disk, and in the hard disk the files are stored. Okay, so just remember the pizza. So files are stored. So we also discussed about how the files are stored, what are the different ways that operating system can decide to store, such as depending on the file system and depending on the format of the files. Okay, so Excel sheet is not a simple text file. Simple text file simply has binary data, something like this. So all the files will contain binary data. In Excel, in text form. In text, what happens is this byte data stream or the byte stream can be converted into some format. The most popular format is called as ASCII. So what the programs do is, so they look at the file and they read depending sometimes operating system finds the file with the extension name. So if you name file as txt, operating system automatically knows that the program that needs to act upon this file to open it is by default it is notepad. You can change that notepad to say notepad plus plus or whatever. So but the basic data stream or the byte stream remains the same thing. So the program is hardwired to read these sequences as byte streams. So basically let us consider that one character takes 1 byte. So say A, B, C, D, whatever the so this takes 1 byte. So the program when it sees the byte stream, what it does is it reads first byte, 1 byte, and then it translates that byte into ASCII. So if A's value is 65, so it is the ASCII value of 65. The reason that we need ASCII values is because everything is binary data, and from the computer point of view, but the monitor and the monitor needs to print this character. So it needs to slowly draw the pixels on your monitor like this. So this is abstracted, but it happens so fast that we don't realize. So in order for it to draw uh, the program needs to send the command to CPU that, okay, I have interpreted this particular byte data as A, and the subroutines in the operating system call, it tries to print onto the shell which is on the monitor. So this is about how we interpret it. So at this point of time where if I simply look at the hard disk and say, if you have a superpower just to look at the hard disk and read the byte streams, you won't be able to make out what is on the hard disk, because there are simply magnetic fields. So the idea is to make sure that these files are organized in a certain fashion, and then this can be read using certain programs. So that is the job of operating system. So when you install operating system, it installs basic programs such as Office suite, Microsoft. If you install Windows, Microsoft document, Excel, PowerPoint, all this will be by default installed, but all the files on the hard disk is just the byte stream that we are looking at. So it will be just 1010, so whatever the byte stream is there. Okay, so this is about the text file. So the program which reads this byte stream is programmed to convert the bytes byte by byte. It will read, and it will display it on the text pad. Okay, this is only for our visual purpose. Of course, you can open the file and work on it in the background, and without even seeing it. Okay, so this is how it reads. So why do we need other formats? So what is the necessity of other formats? So the text file is only for simple text, so it doesn't have an organized structure. So in fact, you cannot insert pictures into the text file or anything like that. So in order to enhance the user experience and to put the things in an order that visually users can make use of it, so things like Excel sheet was invented. So we mostly in our day-to-day life, we see data in terms of we can express in terms of tables. So a lot of things, for example, your say grocery list. So if your mom gives you a grocery list, it's in the table. So if your teacher gives you marks card, it is in the table. If your manager gives you performance report, it's in the table. And there are tables everywhere. In fact, if you try to search contacts in your mobile, it's again a table. So if you just open a chat, so again it looks like a table of contents, chats, and this. So we humans are used to look at the tables, and then we easily can interpret the data. Okay, so the Excel sheet helps us to realize that. Okay, so now let us try to understand how the Excel programs actually so how can we make it different than the text file. So that is where there is a need of let me select some color. There is a need of new file formats. So this is a text format. Okay, I was happy. Okay, now how do I represent the table data? So how do I make sure that this simple byte stream can be interpreted as an Excel sheet? Okay, so that is why there is a need of let me just get out of this, clear this, and let me get into drawing mode again. Okay, so so we had a simple byte stream 101010, something like that. Okay, so this, of course, this text Excel sheet can be interpreted as a text file. So if we try to open an Excel sheet in a text file, of course we can force that. So what we see is we see junk characters. Okay, we did in one of the classes, so today also we'll try to do that. So of course it can be interpreted, there is no problem, but it doesn't make any sense. So why it doesn't make any sense is because there is a specific program to read this, the same thing as byte by byte. So it reads one byte, second byte, third byte, and till the end of file. So every file has something called as UIF, end of the file, and also it has something called as headers. Okay, so this header and end of file is what defines tells the program such as your XLS, or what do you call that, Excel sheet, Microsoft Excel. Okay, Microsoft Excel program, to identify that program. So how it starts reading and how it starts ending the file. Okay, and then internally it has program, maybe the tables are represented in an XML format, maybe, so in the background, so we do not know that. So maybe they have some kind of data structures to read these bytes into a tree structure, and then this tree structure can be put into tables like this. So that is the internal implementation. We don't have to worry about that. But in fact, if you see a new Excel sheets, so you can also choose to store it in XLS. It is an open format. That means initially when Excel sheet was put into operating systems, so that Excel sheet couldn't be open in Linux and Mac and things like that. Now there is a open format which is called as XLX, so you can read about that. So in the background, all this data is somehow put into XML, and there are metadata. So metadata in the sense data of data, so how it is internally organized, and then all the programs can read it from that common format. So it can be portable, so that is portable, that's a portable format. So now what we are moving from is so simple byte stream, and then there were proprietary programs which can read this data, and then the next level is coming to a common ground where all the operating systems can be it can be supported on multiple operating system. So the takeaway from this is that there is a certain format which can be parsed and make sense out of it. So that is the takeaway. So these are all the challenges that any file has. So in terms of Excel sheet especially, so how the data is presented to user. So it is since we have already seen those, I'll just take a read. So it has a sheet, and this sheet, when you open it, you have multiple you can create multiple sheets in the below. That means the one big file, and internally you can create a number of sheets, and then in this each one of the sheets there are tables like this. So in this table we try to put the data, and this, once you save the file, once you open the file, it is still in the RAM, and then when you do Control S or save, so this gets saved onto the hard disk. Okay, so this is the idea about Excel. So now we can from now whatever we have learned from Python, the main thing is to think about object-oriented way to interpret things. For example, we saw a car, and we can interpret the car into objects and sub-objects. The main object is car, and there are several objects inside the car. So one of them is gear, clutch, and brakes. Similarly, we can visualize Excel sheet as one big object. This is a file object, a simple file object which we have seen already. A file object is nothing but which is lying on the hard disk, and which can be opened by simple open call. So this open call from the Python, it calls the open routine of the operating system that is lying around. So if it is Linux, it will do one thing. It is if it is Windows, it will call another function. So that is left to the Python interpreter. We don't have to worry about that. So once we open any file, the file is ready to be consumed with a variable. So it returns a file descriptor. This descriptor is nothing but it points to the first byte or the first location of the file. Okay, so that is why we call this a file descriptor. So fd is just a variable. You can call it as x, y, z, whatever you want, but usually when we try to write programs, we make it to write in a way that it is readable. So fd is a common variable. Just tells that is a file descriptor. So this points to the first byte. Now if you simply open this, we got the file descriptor. So if you had to write without using libraries, you must understand how internally the Excel sheet is organized. That means you need to understand read the format of Excel sheet in the background and how the data is organized. Say for example, if I write marks here and then some numbers here, so so 2, something like this. So how do I represent this m and this 2 in Excel sheet? So this falls in, say, column B of say row 3, something like that. So how do I know that this particular m character m or the string m falls into 3b or b3? So how do I represent this data? So we must understand all these things if we do not use the library. So we need to take the raw pointer and do all of these things. So that is this case is true for all the file formats. For example, if you can in fact open a ppt, you can open anything that is lying on the hard disk with just simple open call. And the problem is for programmers, it's unnecessary and it is a repetition of work. So there is a principle called as DRY, do not repeat yourself. That means do not reinvent the wheel which is already there. But it is important to understand that okay, this all this has a lot of internal implementation complexities, and all these are abstracted into a simple library, and now we can visualize this Excel sheet in terms of objects. So this entire thing can be as one object, a file object, and then it contains sheets. So if you want to try to draw an object diagram for this, it would be something like this. So you have let me call it as it is called as a workbook in the library. So we can call this as workbook. The entire file can be called as workbook, and workbook contains worksheets. So in fact we can directly jump into this from this concept, but now our objective is not to just learn about the Excel sheet. Objective is to understand some concept in a certain depth, so that we understand how it is implemented internally, and then we jump to the implementation. So if you understand this, then we are trying to develop such pattern. So in fact web scraping is just one of the examples. So we need to take some examples and then break down the things. So that is why we are trying to take this. In fact, we can simply search internet and get the things done, but it has its own limitations. So it has multiple worksheets here. Okay. So this is a big object, and this big object contains smaller objects. So many is as many as you create. Okay. So within this worksheets, we have rows and we have columns. Right. Within these rows and columns, so we can write text. We can put some data inside that. Okay. That means we need to know the rows and columns. If I say put your address in an Excel sheet, so where do you put? So it's difficult for computer to recognize. So where do I put this? So it won't ask questions. It will just stop the execution because it doesn't know what to do with that data. So if we tell, okay, in this workbook called as sample.xls, and in this worksheet called as or numbered as 1, and the given row is 100th row, and the column column would be something like 7th column. Put this text. So we need 3 points to put the data, put your address into the right place. So now I can tell that, okay, put this address in this file, in this sheet, and then in this column, and this row. So now we have specifically told the computer that, okay, this is my location. So now the computer won't complain, and it will try to put the data into the worksheet. Okay, so that is about the object oriented thinking of the workbook. So that is how the so there are three levels of objects involved here. One is the workbook. So this is the first one. So this is the second layer, and this is the third layer. So now we need to understand the library. Of course, you can write your own libraries if you know the formats, but there are several libraries. One of the libraries that we are going to use is called as XLWT. So these are popular libraries. So for WT stands for write, Excel stands for Excel, so it's used for Microsoft documents. And then there is XLRD if you are just want to read, you don't want to write. So these two things are two libraries are separate. One is used for writing, and one is used for reading. You can simply do pip install XLRD, and then it will simply download the library, okay, and then put it into your Python package. Okay. So this is the main concept behind the Excel sheet. This is about the visualization. Now let us get into code and then try to realize this. Okay. So remember, the key point is any data that is on the hard disk can be interpreted as a simple byte string. By default, open system call can read it as a text file. So it cannot read any other file because it doesn't know the internal format. So metadata, how the data is organized, and things like that. Okay. So let me get out of this and let us get into code. Okay. So this is your Excel sheet. The complete sheet is your one object, and then this particular sheet is second level object, and these are the third level objects. So if you consider a file as first level, and then these are the leaf nodes kind of idea. So if you write something like hi, then it has a particular memory. So hi, hello. So hello is in C3, and A is in 1A. So we need to tell that specifically to the computer. Okay. So let's go to the program. And let us try to where is that the report? Okay, here it is. Okay. So what we're going to do is we are going to what is our final intention? Final intention is that we have an empty Excel sheet here. Our idea is to populate state here, and then say active cases here, and maybe diseased cases here, maybe cured cases here, discharged or cured, whatever. So like this, and then we have something like Karnataka, and active cases maybe 3,000, something like this, and this is maybe some 200, cured maybe some 5, 6, something like this, and similar for all the other states, Delhi. So all of them will come here, and then you prepare an Excel sheet, and our total the final motive is to send this Excel sheet as an attachment to the mail. Okay. So the first thing that we need to do is to extract the state-wise data. Okay. So this we did as one of the exercises. So I'll just show that. Where is that? Okay, here it is. Okay, COVID state is that one. So what are we doing here? So there is a function called as get total number of get total cases here. So what it does is it goes through all the states and gives that particular the element. So that element was in a JSON, something like it's not this. Where is the JSON? Subscription code sample. Okay. So this was our JSON. So our one of the programs was to, for given state, extract the active number of cases. So we are going to reuse that particular code and then modify slightly, and then we will use it for the for populating the Excel sheet. Okay. So let us try to use that. So this is that program. Let us try to see if it is running. Okay, let me copy this somewhere. Where is our project? Okay, it's already here. Okay. CD input data. Okay, and then there is COVID stats. Right, then COVID stats. Let us see if it is working. Okay. There are no items here. Okay, that is because we have removed some of the. We will try to extract it from line 33. Okay, extract the data here. Let us see if the data is extracted. So this is a problem when you write code and then get back to it. You need to kind of get used to it. Import a PDB. You can put it like this, and then PDB dot set trace. The idea is to just to jump into each of the lines and see whether I'm getting the necessary data. Enlarge this. So the instruction pointer is at this point. So let us see if the state was that has some data. Okay, it has data. So what is the problem? Now let's get this district data. Please. Okay, district data, this is also fine. We'll go to the next level. Next level is at 35. And then we'll just move on. Okay, let us see if this data is collected in count. Let us see what is the count now. Count is 0. So we need to find out. String has no attribute called as items at 37. So let us look at this. And get total cases at this point of time. So let us try to print something and find out what is happening. District name, D name, and then value, d underscore value. And let us try to run this, and we'll get whenever it crashes. So this is one of the ways to debug. So it's okay. Now the problem is string object doesn't have object. Okay, so this is the latest the last printed item. So do we need items d value? So string has no object called as. So d value is this. It is complaining that it has no attribute items. But this is in fact it is a dictionary, or it is interpreting it as a string. Value dot items. Now our challenge is this value. So let me try to print so one more level of we try to extract one more information. So let us try to print the type of dval. The problem here is we are trying to interpret this data as a map. So there are maps inside maps, and then we're trying to extract the items out of this. So maybe in one of the cases we do not have the necessary data. Okay, this is dictionary, interesting, but why it doesn't have values? String of it has no items. District value. Okay, dval. Print. Let me try to force it. Items. So these are the various levels of debugging. So you find out one thing and find out another thing, and things like that. Dictionary items are this. Okay, notes and unassigned value. Okay. There is a district called as unassigned value. So what we'll do is we will handle this particular problem here by putting this into the, let us move this whole thing into try block. So how many lines are there? Maybe 14 lines. Try block, and then we'll try to handle that that situation by doing except what is the exception that we are getting? We're getting attribute error. So this is just a alias. So you can simply leave it like this, or else you can even just give a variable. So in this case I'm just going to print something like print attribute error. So I can also print I can convert the attribute error object into a string just by typecasting it AE, and then let us try to get out of this problem. What is the problem? Invalid syntax. Where is accept. Try. Okay, it is here. Okay, that is indentation level. Let me indent this back. Okay, good. So let me see if the count that is expected. Where am I calling this? Okay, I'm not calling this anywhere. I want this as well. Why is it coming as attribute error? Okay, I'm returning count here. I don't want to return it at that point of time. I can accept this block. Further, okay, count is equal to active. Let me see if it is getting counted properly. So now we have several variables to work with. Okay, it's just getting out of this. That is because this unassigned value is of type string. The key and the value. Let me try to accept this at this point so that I can minimize, or I can further narrow down the problem. Line number 13. Okay, the whole block needs to be re-indented. This block, so 33 to 40, 13 lines, 14 lines, re-indent. Okay, we are stuck here. We are not catching this at line number 33. Okay, let us do one thing. So the main culprit here is this guy, unassigned value. So the problem is we have a list of states in the JSON structure, and then we have one item which is outside that block. So that is there is a problem here. So that is why we are unable to get this in the normal course of parsing. So let us try to do one more thing. What we'll do is we will pop out unwanted item. So that is unassigned value. So what we'll do is we'll just try to look at the keys, and then we'll pop out unwanted key. That is here there is a key called as unassigned value. So that is coming in between. So let us try to get statewise items keys. So these are dictionary keys. Okay. And then this particular guy doesn't have any structure inside that. I think this was added recently in the API, so there is some change in API and there's a new value added here in line number 33. So most of our time usually goes into the debugging, so we need to understand this unassigned value. If dust is equal to unassigned value, and just continue 1 2. So here as well I do not want this. In fact, I can go and remove the key. So that is one of the solution. Another solution is to find if the key is unassigned value, because that is not that is not in the format that we expect. So this is the only invalid syntax. So this is one of the common mistakes that we do as a programmer. So usually we try to equate with 1 equal to sign. So that is an assignment statement. So then let us try to run it again and find out. Again at line number, okay, this before, okay, this even before this. Let me put control at this point as well. Now I think it should work. And we should make sure that we are using the right variables. The district is fine here. Here it is district name. So if it has unassigned value, don't do anything with that except that. So this is actually the change in an API. So that API has some changes which we cannot control. So we need to modify our code in order to handle that particular case. Again, unassigned value, string has no value. Continue here. Let me put this is at line number 33. This is okay. Line number 33. Object has no attribute called as items. Okay, let me put one more control. Statewise data. So is statewise data coming in properly? Statewise data. Let me pass this as state. This so it is coming. Okay, it has items. Okay, it has all the items. String object has no attribute items, but get total number of cases at line number 33. Yeah, try to, yeah, you can suggest suggest any ideas that you have. So what we're trying to do is we're trying to accept this particular guy who is a rogue entry in the JSON. I think the JSON is changed now, so we have a rogue entry. So what I'm trying to do is, if I get this key, so just continue with do not process the below block. Okay, so this is one of the variants that you can face while coding. Okay, let me put if state-wise data is our dictionary. There is a function called as is instance dictionary. Only then you do this, or else just return. Okay, so I'll just, if not, just return. Let me see if it works now. What is happening? I'm getting the data from if is instance this state-wise data dot items. Again, this is crazy. Then it should be some silly mistake. So it's state-wise, because this program was working, if you remember, in the earlier class. I think they have changed the JSON structure now. Has no attribute items in the state value. Get total number of cases. This is fine. This is fine at this point. I am getting stuck at this point. Line number 33. I'm not saving this. Okay. Am I in the right path? My input data code stats .py. Okay. String has no objects and items. State-wise data. Yes, there is no spelling mistake. I try to look closely. Then is instance let me quickly show you the program that was written in the last class. Let me fix it later. I will show you the execution program of this particular guy in the old previous class, because that was written live as well. So input data reports, COVID stats. Okay, we have written here, then reports, Python COVID state by stats. Okay. Let me try to get state-based data. What is the argument that is missing here? Let me quickly get this, copy this, and I'll just put it here. I'll just rename this. Give me 5 minutes. I'll fix that problem, don't worry. So this was from the previous class. I'm just copy pasting the same program, so it's because we don't have to spend a lot of time in debugging, but just learn that these are the ways to debug as well. So the problem here is there is a rogue element which is coming. We are trying to get out of that. So there are several ways to do that. Either we can go through the dictionary and then remove that element, or you can if you face that element, then just do not execute the below statements, but just continue with the other states. So that is what I'm trying to do here. So I think there is some other problem. So I'll fix that in by next class. I'll try to explain that, but then let me just try to show you the program, how it works. Statements, data. Where is that? Okay. CD input data, and then Python COVID stats. Line number 52. I don't need this. Okay, at least this is working. Print count. This is actually working. Okay, see here, what we're trying to do is we got the data from outside forget report. There needs to be some fixing needed. So let me just use the same. So similarly, in the last class, I think we had some other problem. So we put, this is one of the other ways to get out of the problem. That means if it is dictionary only, then go to next line, or else do not do this. So that is one of the other ways to handle that. So what we're trying to do is we are trying to get our total idea. The final idea is to put the state name here and put active cases here. So we can take that. So I can use this same function in our reporting module as I'll show you the program which is already there. This is actually a simple program. So what it does is it takes the dictionary that we are passing, and then it gets the total number of cases. So what we're trying to do to put we need to populate the first header that is put here. So I'll come to that. So you need to get all the state names. You can get all the state names just by doing that dictionary dot keys, and once you get all the state names, so you iterate through the state names and reuse the same function that we are trying to write here. So for every for every state, given state name in the list of states, just get the total number of cases and update a map here. We are using a temporary map, so this map will contain state name and total number of cases, which will be mapped to total number of cases and a state name. So these are all small maps. Karnataka and Kerala, Andhra Pradesh, and all these are all small maps which are aggregated into a list of rows finally. So we are updating that into a map. So get all the states and all the active cases here, and then what we do is we once we get that data, the complete map, so we are converting that big JSON, which was like this. So what we are trying to do is okay, sorry for taking time. Let me just finish this up. So we input dictionary is like this. So we have Karnataka, and inside that Ballari and things like that. Then we have in the same line we have Kerala, and then Andhra Pradesh and things like that. So once we pass as an argument Karnataka, so what we're trying to extract here is we're going to extract active number of cases. Okay, so this is old. So now the active cases in Karnataka during that time maybe it was 39. Today it is in thousands. So so this is the dictionary. So we are just trying to extract these two values, and these two values will go like this. So this is the final dictionary. This dictionary is converted to this dictionary Karnataka, and then active cases. So now it is something like 3000 something like this, and Kerala like this. So we are converting this particular input dictionary into another kind of dictionary. It's just a simple extraction, but we need to write code to format it like this. So once we have this format, we can simply iterate through each of these entries, and then populate the Excel sheet. So populating Excel sheet is very simple. It takes only few lines of code. So main idea is to convert the data. So it's like a this is like a one big basket you have, and then you are picking each of the states here into like cherries, and then you are putting back into the states here. So that is how your variable visualization should be. So imagine that this is like a big basket, and these small items that you're extracting are like cherries or apples, whatever it is. So then you collect here. So in next loop you collect another cherry. The first cherry was Karnataka or whatever in the order of JSON. Second cherry was Kerala, like that. So iterate through all the 30 or how many ever number is there. So all the states, and then you have small cherries here, and then this big basket is sent as an argument to this function create XLS, and then this is just a file name. The reason that we need to pass the file name is because the open call needs a file name to open a file. So that is about the file name. So this create XLS is defined here. So it takes this big basket and the file name, and it creates, opens an workbook, and then it adds a sheet. So we discussed that the Excel sheet, the complete Excel sheet is a workbook, and then inside that we have sheets. So we are creating one sheet, and then inside that sheet we are going to write the data. So let me just get exit out of this. Okay. So this is all the code that it takes to populate the Excel sheet. Okay. So we need to take that pointer, and that means every object has a object address. So this is an object. So in this object we are adding another object using this function, and in that object we are going to write. So row and columns are just numbers. So so 0th column and a column is starting from a 0. So 0 stands for first row and first column. So here in our Excel sheet, so this is our 0 0. So it is not it looks like a column here, but in this library we interpret that as 0, and it is only for viewers or the users that it's the first row, but for programmers numbers always start from 0, because we try to address arrays from we call it a 0 and indexed array. So 0 0 means the first row, first column, and then right next to it, that is the first column, that is nothing but active here, and then you kind of write it here. So this is nothing but 2 more minutes. So this part is here, this part is here. So this part is here, and then we are going through the loop. That means what we have got is we had a big basket of a list of states and active number of cases, Andhra Pradesh, Karnataka, Kerala, like that, and we are going iterating through that. We are trying to enumerate this, so I'll come to the enumeration part. We are trying to enumerate it because we need the numbers to populate. That means instead of this particular each of these values has key and value pair. So when you try to enumerate this, what happens is enumeration is nothing but giving numbers to this, that's all. So 0 1 2 3 4, so each of the items in the dictionary will get enumerated. So that enumeration is nothing but instead of, now we used to get in a dictionary, if you do dot items, we used to get only a key and value. So when you enumerate the whole dictionary, we also get a number. That means it's just like row numbers, and those numbers we can use it to populate the dictionary. So write Excel sheet row and then column and the state. So in this row, in this column, put this value, that's all. So this is the state name and this is the active cases, and then I need to populate those two values. So what I'm trying to do here is, let me change the color or else it will get confusing. Row and column, I got the numbers because of the enumeration, and then in our case, row is always increasing. The columns are actually fixed. That means first column and the second column. In the programmatic way, it's the 0th column and the first column. So column is equal to 0. So you do this, attach state to column, this column, and row is always increasing. So row numbers, anyways, we have got it here after enumeration. So get all the enumeration and put it one by one, but columns are just like 0 and 1. So that is why we're just incrementing column plus 1 here. So then all the states, it gets, Andhra Pradesh comes and sits here, and the next states, the Arunachal Pradesh, Karnataka, and all these states come, and all this from this basket, they come one by one and they start getting populated here. So that is how we try to populate the Excel sheet. So this is one of the raw ways to do it. So in fact, if you use Pandas library, so data is interpreted as data frames, so you can read about it. So these data frames can be directly dumped onto the Excel sheet. Okay, so you can read about that, but you need to know the how exactly the data is written. So that is the reason that you need to do this particular exercise. Okay, so this is how the Excel sheet gets generated. So I'll just show you one of the reports from the old project. after running that program, we get this. Um, this is the Excel sheet that we get. So you need to play around with rows and columns, and then you understand what is happening. So you can do a lot of things. Right now I'm printing only active cases. In fact, the assignment is to get deceased cases and the queued cases and drop it here. Okay, so that is the assignment. So any questions, please let me know. And I wanted to do the live programming because I want to show you what are the problems that you face. That is part of the session, because by doing, because as I said in the first few sessions, mostly about 80% of the time we spend in debugging. There are for every problem we have multiple solutions, and we need to choose solution quickly if we do not have time. If we have time, choose the best solution. In our project, in our current implementation, we faced a problem. That problem was one of the rows or one of the entries was unexpected entry, and it was causing a lot of problem. So we tried to debug it, and it took a lot of time, so I left it there, and then I took the program which we wrote in the previous class. And so in our current program, we are trying to accept it by just checking by its values. So in this program, we are just seeing if it is a dictionary, only then proceed. So that is one of the, there are two solutions, so we are trying to choose one of the solutions, that's all. Okay, so we will face a lot of errors, and that is why I have allocated 1 hour. It is expected that we spend about 20 minutes on the errors and such things. So okay, and some things where we cannot write program live. For example, web scraping is a little bit difficult, because I took almost like 2 hours to write that program. It looks small, but we need to understand the structure and then write program. So that is, whenever it is not feasible, I'll write it offline and share it in the class. But as far as the programming is concerned, I'd like to show live. Let me know if you have any other thoughts, if you cannot follow up, or if you need programs beforehand, so I can send it as well. Because these programs I have already, it is easy to just drag and drop here and execute it, but doing that won't give you a lot of learning. So that is the idea. Okay, so that's all I had to share. So any questions, please ask. So there, yeah.
Hi, Digan.
Hi.
We want to open one file system, and we want to make a VLOOKUP with the other sheet, and make a new data in the new sheet with reference to the big data, raw data. So can we do like that, like 2 sheets? One is the raw data with the
Yes, you
big
can.
sheet, and I want to take only 5 states data in the other sheet.
Yes, you can do. What you can do is you can currently we are using one of the libraries called as XLRT. Sorry, WT. Okay, here. So this is the library which does writing. So what you can do is reading is again a simple thing. Just refer the XLRD RD library. So I'll just show you how to go about that. So that's a good question, because usually we try to make some data out of already existing data. So Python XLRD is one which reads Excel sheet. So in fact, you can do that in pandas as well, but you need to know the data structure first. So XLRD is simple. Let me try to XLRD. Let us just read one of the examples. You can do that. So idea here is in your example, you just use this library and just open the workbook, and then you can in fact open the worksheet by index or by name. There are multiple functions to that, and then you can get those read those values like this. There's a similar case. Just instead of writing, you can just open the workbook and then this is workbook. So we had a big object called as workbook, and there is a smaller object which is called as sheet. So you can get the sheet which you want to read, and then you can read those data row by row. You can simply write a for loop, and then you can get instead of here they're doing only a single cell value. In fact, you can write row by row, and then initialize the row is equal to something, and a column is equal to something, and then extract the data. Once you extract the data, it depends. For example, I have raw data something like ABC 4 3 something like this, XY something like this. So if you have this raw data, and maybe you would just want to extract these two values, what you need to do is you need to write a program. Let me get into raw drawing mode. You need to do the following. So once use that particular library and extract this data, because you are using a loop and reading for row column, and then you specify the range of or you can simply search how to read through rows and columns. So you'll get a ready-made program. So but they won't know what exactly data you want to know. So once you start iterating through that data, so you will have row wise data, and then you'll have column wise data. So idea is to take one of them, make one of them as a key. For example, column name, I can make it as a key. Say for example, you have a header something like name and marks. So what you can do is you can create a dictionary with name, and then you have the value ABC, and then this is a dictionary. You can have marks as another value. So here it is like 3. So this is a small dictionary. So what you can do is, once you collect this small dictionaries, that means you're collecting each rows. So you're collecting row by row. So you have collected one row here, similarly you collect another row, and then just append that to a bigger map, or a list is better. So you can just update a list. So you will have list of small dictionaries. So those dictionaries will contain name and marks. So once you get this data, take this data. Now you have formed a data structure, a list of maps, and then iterate through this for this particular entry, for list entry E in this particular list. Iterate through that, and then use this library, and just use that XLWT library, and create a sheet, or if you have existing sheet, you can operate on that. You can create a sheet, and then you can dump this data. So key idea here is to interpret your data that is in your other Excel sheet into a right data structure, and then filter it, and take whatever data is required. For example, you don't need this column C, so you don't need to add it into your small dictionary. So that is how you can do that.